Welcome back. In this lecture, we are going to cover least sum of squares technique. So let's get started. Okay, so least squares fitting is simply a way to find the best fit curve or line for a set of points. So if you guys recall from the previous lecture, is that we went to the field, we went to the human resources department, we collected data, and we plotted the data, which is simply here I have my salary versus the number of years of experience. We plotted all these data points, and now the big question comes: which straight line should I fit to that data? Should it be this straight line? Or maybe should it be a little bit more horizontal straight line? Maybe a little bit more vertical straight line? Well, I don't know. And that's why we apply the least squares method to try to obtain the best fit line. So let's see how does that happen. So what we do is that we assume, for example, that here is my best fit line. So what we do is that we simply calculate the difference, which is this distance, okay, between my training points, which is my actual points, these gray points, these are the actual points that I collected in the fields. That's what we call it ground truth, okay? Actually, if you guys can see here, this is what we call it actual. And we call this yi, indicating that I have y1, y2, y3, and so on. And these are the actual points. These are the true ground truth point. Here, this straight line is coming from my model, right? And that's why we call it y hat. So this hat stands for estimated, okay, or predicted. So that's what the model is predicting, okay, which is any point that here appear on the straight line. These gray points here, these are the ground truth. These are if the model basically goes through all these data points, that's great, I have a perfect model, okay? So what we do here is that we calculate the distance d. And this d is simply the distance between the actual and the estimated. So the distance d equals to y hat minus y basically actual. So after we calculate that distance, what we do is that we calculate the distance basically for all the data points I have. So I actually again calculate it for this distance, for this one as well, for this one too, and so on. And then what we do is that we take all that difference, we square it up, okay? And that's where the term least sum of squares, so it's called sum of squares because I'm squaring here all the error or the offset, or another term for it, we call it residuals as them up. So now I sum them up. Think of this as kind of the aggregated, this is the summation of all the errors that I have. So if I run an optimizer on this value and I try to minimize it, just try to come up with the minimum value, then that means now I will have the best fit line that could go through the data, because that straight line will have the minimum distance or the minimum error between the line and all the data points that I have in my training data, okay? And that's simply how do we obtain the coefficients or the parameters m and b. Please note that there are tons of other ways of obtaining the values of these coefficients. This is just one technique, just a very simple technique, and I just want to give you an idea because we're going to apply this technique when we train the model using sklearn or scikit-learn. I'm going to show you guys what do I mean by that, okay? All right. So the last point before we cover the details of SageMaker and actually start to build our model, what we do in general is that we take our data. So this is all the data that we collected, which is the number of years of experience and the salary. And what we do is that we divide that data in general into what we call it training data and testing data. For example, let's assume that I have 100 samples. So what we do is that we generally, kind of as a rule of thumb, we divide the data into 75% for training. So in this case, I would have 75 training samples. And we divide the rest, which is going to be 25 data samples for testing. A very important point here that we need to make sure when we build any machine learning model is that we want to make sure that the testing data has never been seen by the model during training. This is very critical, okay? Think of this as, like you have, for example, at the university, we basically like teach concepts to students, right? So think of this as the training, okay? And then what we want to do is that we wanted to assess the learning or assess the understanding of students to the concepts. So what we do is that we make them sit for an exam, right? So a very important point is that you want to make sure that the exam does not exactly contain all the questions that you covered during training, during, for example, the lectures. Because that means now the students will simply memorize the data and we're not going to generalize the data. And this is very important. What we want to do when we develop any machine learning model is that we want to make sure that the model does not memorize, but it's capable of generalize. We want the model to generalize. We want to learn the idea, the concept, and then when you deploy it in practice, it will still work as long as the data, again, it's quite, I would say, from a very high level, came from the same, I would say, distribution, or it's kind of similar. If you, let's say, training an image classifier model to classify, let's say, cats, okay? So you are teaching the model on images of cats, and then if you bring in a new cat image, the model should be able to make predictions as well, and should be able to classify the image as a cat too, okay? So this is very critical and very important, and we're going to show you guys how to do that and how to divide the data into training and testing in scikit-learn when we go and build our model in Jupyter Notebook. Okay? All right. So again, if you guys want to read a little bit more about least sum of squares, you guys can check out these two books as well. And you can refer to page 124 in the first book, Understand Machine Learning, and you can refer to page 62 in An Introduction to Statistical Learning book. And that's all what I have for this lecture. I hope you guys enjoyed it. Please stay tuned and please enjoy AWS SageMaker practical course, and I'll see you guys in the next lecture.